Bismillahirrahmanirrahim. Hello and welcome to Dr. Saqib Khan Science Academy. Today we will learn about determining the equilibrium concentration or CE value. I got a lot of questions about how to determine or how to calculate the equilibrium concentration of your adsorption experiment. Actually, I have seen some videos on YouTube. People have determined the CE value, but I think that calculation or that explanation determination of CE value is a little bit misguided. Actually, in those videos, they have determined the equilibrium concentration, not the equilibrium concentration, but the concentration from the absorption values. They have the absorption data, and then from that absorption data, they made a calibration curve, and then from calibration curve, they converted the absorption value into the concentration value. So that is not actually the equilibrium concentration. For equilibrium concentration, you should know that you have to determine the equilibrium time. Equilibrium time is basically the time at which the adsorption and desorption become equal. That is your equilibrium time. And the concentration at that time will be the equilibrium concentration. So to measure the equilibrium concentration, you have to run time experiment. You have to run the time experiment. What is time experiment? You have to do the adsorption experiment. You have to do the adsorption experiment for a longer period of time. In our case, we run the experiment for 3 hours. In some cases, you can run the experiment for 24 hours, for 6 hours, 10 hours. It depends upon the performance of your material or the performance of your adsorbent, till what time it can adsorb maximum concentration. So in our case, as I told you that we run the experiment for 3 hours. So you can see over here, this experiment, I run this experiment with initial dye concentration. The dye which I used was RO16 dye. The initial concentration of that dye was 100 ppm or 100 milligram per liter. The other experimental conditions was dose was 1 gram per liter or 1 milligram per liter. At 30 degrees C temperature, we did it in summer, so the temperature was 30 degrees C, or our shaking incubator, we set the temperature at 30 degrees C. The volume which we used for the experiment was 20 ml with the mass 20 milligram, and agitation was around 150 rpm, revolution per minute or rotation per minute. And the adsorbent which we used was activated carbon. This activated carbon was activated with H3PO4. So we did the experiment. We took the reading at 5 minutes, 10 minutes, 15 minutes, 20 minutes. Till 20 minutes, the sampling interval was 5 minutes. After 20 minutes, our interval was 10 minutes. From 30 minutes till 120 minutes, our time interval was 10 minutes. After 2 hours, our time interval was 30 minutes, 150 minutes and 180 minutes. So in total, we run the experiment for 3 hours. We got some concentration for each time interval. Now we will calculate the QT value. You know how to determine the QT. QT is basically the adsorption capacity at time. Adsorption capacity at time. So this was our formula, C0 minus CT multiplied by volume divided by mass. So we will put this formula, C0 minus CT multiplied by volume divided by mass. As these values we will use throughout this formula, so we'll log the columns. Actually, this is in ml. So in liter, it will be equal to 0.02 liter. and this will also be equal to 0.02 liters. Okay, so this value is in liter and this value is in grams. Okay, so now we'll copy this formula till the end, and then we'll calculate the removal. Our removal is equal to, or removal in percent will be equal to C naught minus CT divided by CT multiplied by 100 or 100%. So we'll put this formula. So we will put this formula over here. This will be equal to C naught minus CT divided by divided by initial concentration multiplied by 100. So this is this much percentage. So we'll copy this formula throughout. So percent removal or QT is almost same in this case. Now what we will do, we will plot a graph of percent removal or the QT, a scatter plot. We'll plot a scatter plot this one plot. This is basically the CE measurement. This is basically the CE measurement. Now you can see that with the time lapse, the removal was increased. This means that there is more adsorption. But over here you can see that after 60 minutes, these lines straighten. There is no much removal. There is no much adsorption. You can see that these lines become straightened and there is no much adsorption. If there was adsorption, these lines, it can go like this, but it is going in straight line. It is going a straight line. There is no much adsorption. So we can consider this 60 minutes as our equilibrium time. So we can consider this 60 or 70 minutes as our equilibrium time. You can see over here that at 60 minutes, removal was 71%, then 73%, and till 3 hours, only 77%. This means that only 6%, 5 to 6% removal was done in next 2 hours. In first 60 minutes, maximum removal was achieved in first 60 minutes. Later on, this removal was only 5 to 6%. So we can consider 60 minutes as our equilibrium time. So we can consider this 60 minutes as our equilibrium time, that after 60 minutes, not much removal, not much adsorption or desorption. If there was desorption, this measurement or these values could be lower. The removal could be lower than this value. So there was not much adsorption or desorption after 60 minutes. So we can consider this 60 minutes as our equilibrium time, and the concentration at this time is our equilibrium concentration. Okay, this CT is basically CT at 60 minutes. So we can say that our equilibrium time is 60 minutes, and our equilibrium concentration or our CE value in this case is 28.04. So 28.04 milligram per liter. 28.04 is the equilibrium concentration. So this is our equilibrium concentration. Hopefully now you understand how to measure the equilibrium concentration. First of all, you have to run the time experiment for longer period of time. At the time where you get maximum removal, and after that removal, these lines become straightened. That is your equilibrium time. In our case is 60 minutes. After 60 minutes, you can see that the lines become straightened and there was not much removal. In first 1 hour, the removal was 71%, almost 72%. And after that, in 2 hours, it was only 5 to 6%. So we considered this 60 minutes as our equilibrium time, and equilibrium concentration was 28.04. So you will use this equilibrium concentration later on in your isotherms modeling and your kinetics. Hopefully now you understand how to measure the equilibrium concentration and how to measure the equilibrium time and equilibrium concentration. Thank you very much. If you still have some confusion, you can ask over here, or my email address is given. You can directly ask me. Thank you and Allah Hafiz.